All right. So my name is Chris Holdgraf. I'm the executive director of 2I2C. I'm also a contributor to the Jupyter project, and I'm kind of wearing both of those hats kind of simultaneously here. I'll talk maybe a little bit about what that means. My research background is actually in neuroscience. So I kind of came into this world, and I know several people here from my time as a neuroscientist before I kind of veered off of that career path and into the general open technology and infrastructure space. I worked with infrastructure teams running cloud services that utilized interactive computing, Jupyter infrastructure at UC Berkeley, and contributed a lot to many of the projects that you've heard here. So Binder, Jupyter Hub, Jupyter Lab and Notebooks, and Jupyter Book. And what I do now is basically run a nonprofit that sort of swirls all those things together into a collaborative cloud service that I'll talk about a little bit at the end, if I have time. So first up, I just wanted to note, what is Jupyter? So a lot of people don't really know what Jupyter is. They either think it's a product or a company or a single technology. It's actually none of those things. The way that I describe Jupyter is that it's an open community. So it's a group of people that collaborate collectively on the internet. They use, GitHub as their primary medium of communication and collaboration. And they're all dedicated to a common cause of building public tools that facilitate interactive computing, so sort of active human-in-the-loop workflows. Jupyter Book is a sub-project of Jupyter, and it is one of many. So this is just like a tiny, tiny little piece of the Jupyter ecosystem. And most of what I'm talking about, I'm sort of speaking on behalf of that ecosystem. So my organization, 2I2C, is one participant in that space. There are many others. CurveNote and Chime2, which is a group based out of Northern Arizona University, they're both co-leads on this project, and they do a lot of the work that I talk about here. Jupyter Book is the piece of Jupyter that kind of leans into authoring and communication and sharing and publishing style workflows, which has been a big part of the vision of Jupyter for a really long time. And as you may have noticed, it has evolved quite a lot over the years. It actually started in 2018, and it used a kind of finicky HTML generation software called Jekyll that Aga was helping me debug many years ago, and I'm glad that I never have to debug Jekyll anymore. About 4 years ago, we relaunched it using a documentation engine written in Python called Sphinx. And right now, we're in the middle of relaunching the backend engine that powers Jupyter Book, which is something that's based in JavaScript. It's a documentation engine that we call Mist Markdown. So that's why you hear the word Mist a lot. One reason I say this is because we're still in the middle of this transition, which means that if you just go to jupyterbook.org, you're going to be very confused because it's a completely different technology stack. And we're in the midst of kind of alpha testing and transitioning it over to this new fancy Mist system that you've heard about today. So I wanted to talk about what are the guiding principles and in addition, kind of superpowers of the Mist ecosystem. And I think that there are basically four things. Mist is trying to be structured and lean heavily into content as structured data. It wants to be extensible so that people can take its core functionality and build it out in new ways. It wants to be ubiquitous, and by that I mean useful for all parts of the research lifecycle. And it wants to be open. So it's a broad, participatory, inclusive community that anybody can participate in and that many different groups co-leads together. So what do I mean by that? Something that you've seen a couple of times here is a really interesting demonstration where you can kind of pull content in from one document or one article into another. And this is because one of the key principles of Mist and the engine that's powering Jupyter Book is that when you publish something, what you're actually generating is a blob of structured data called JSON. And effectively, this is a well-structured, kind of semantically tagged description of the content on a page that can be used to generate all kinds of different artifacts. It sort of has all of the information that you need to understand what's on that page in a machine-readable form. So when you visit any page generated by Jupyter Book on a website, you're seeing a nicely rendered HTML version of it, meant for a web browser. But under the hood, there is also a little JSON blob sitting there that's designed to be grabbed and pulled apart and reused and remixed by other Mist engines, other data collection software as a part of this kind of vision of interconnected research communication. So what that allows you to do is basically publish something one time, which is this JSON blob of data that is in a sense like the source of truth for what is the document that you are creating. It is well structured, and it is, for all intents and purposes, something that you can use to reproduce a PDF or an HTML version or whatever kind of artifact you want from a source that is like much more archivable and versionable and reproducible than something like a PDF might be, for example. So in some ways, it kind of cuts a middle ground between static PDF documentation and sort of super interactive HTML documentation that's changing all the time. It kind of brings replicability into that space by having a well-structured, semantically tagged document. And so what this lets you do is publish JSON blobs with your article, with your book, whatever, and grab different pieces of data, subsets of paragraphs, individual figures, pull them into other spaces, whether those are analytical spaces where you're trying to do meta-analyses like we saw earlier, or simple citations where what you want is an interactive figure that shows like a hover preview rather than just a link that jumps out to another document. It also lets you connect with other external data sources. So there are a lot of other services out there that publish structured data, and MIST tries to lean heavily into that as well. So for example, if you link out to Wikipedia articles, Wikipedia actually does a really good job of publishing its data as structured content as well. And so you get nice things like hover previews, and I think also opens up a lot of other avenues for interacting with data while you're reading and learning whatever it is that whatever document you're reading. So it's trying to like lean into this concept of bringing content into the realm of computers so that you can do interesting interactive things with it. So the second thing that MIST tries to do is it tries to lean heavily into extensibility. And extensibility is actually built into the syntax that you actually write when you create a MIST document or when you create a Jupyter book document. This is just one example. It's called a directive. And it's basically kind of like a function, but in Markdown rather than in a language like R or Python. You can define a name, you can give it arguments, you can give it key value pairs, you can give it chunks of content. And what JupyterBook knows how to do is basically take different kinds of directives and let you define different kinds of directives that result in different kinds of content outputs. So here's an example at the top of something called an admonition. You can define a figure directive that has all of the arguments you would want for things like citations and references and captions, or you can even do little, user interface quality of life enhancements by creating little cards, make them clickable, create grids, create drop downs. A lot of the stuff that you saw in some of these earlier demos. The idea is you want to have a markdown language that is flexible enough to capture all of these different use cases using the same basic structures for all the same reasons that it's really useful to be able to define arbitrary functions in a language like Python. The other piece of it is we want MIST to be something that is useful across the entire research lifecycle. So that means everything from the very first day that you're learning about a new idea or a new workflow to the very final day that you hit publish and you send it up into a preprint server. Bringing the capabilities of the MIST engine and cross-referencing and evaluation and things like that into a live JupyterLab kernel environment. And the idea is that you want to be able to use MIST from day one to day N so that once you get to that point of communicating out your research and publishing, you don't have to completely switch your workflow into a different tool chain. I think one of the biggest challenges in open science right now is that the tools people use for their day-to-day work, Python, Jupyter Notebooks, things like that, are very different from the tools that they use to communicate and write, like LaTeX, for example. So by having a single tool chain that is flexible enough, you're going to be able to utilize it throughout each part of the process and reduce the kind of energy barrier that you have to overcome in order to communicate your work out in a more reproducible way or send it to a preprint server or a journal like NeuroLibre. And then finally, I think in some ways the most important aspect of MIST and the Jupyter ecosystem is that it's driven by a community. So the MIST team has a steering council. It's made up of 3 organizations right now. It's 2I2C, CurveNote, and the Chime Group at Northern Arizona University. It also has a broad and inclusive team process. So we have what's called a team compass, which is kind of like a little guidebook to how you can interact with the MIST team in general and get more involved in cycles of development with the MIST community. And I think that in many ways, that's one of the most unique aspects of projects like Jupyter, because that's what makes communities and technology like this resilient and scalable, because you are co-creating something together with a group of people all across the world. And as a result, you have all of these different ideas kind of pouring into the same technology. And it means that if any one of these stakeholders leaves, there are other people that can remain and kind of carry the project forward. So that brings me to the last couple of slides of this talk, which is about my organization, 2I2C. So as we've been managing these kinds of infrastructure for communities over the last couple of years, I think two different needs came up over and over and over again. One of them is open source communities need a lot more support than we often think that they need. So tools like Jupyter are ubiquitous. They're used everywhere in the world. But I can tell you that the amount of funding that projects like Jupyter have relative to the amount of impact that they have is hair-raising. It's really surprising. You would think that something as successful as Jupyter would have like a well-maintained, well-paid team of full-time developers behind it. Completely not true. It is still in many ways like a nights and weekends project made by enthusiasts, made by companies that allow people to spend parts of their time contributing to it. So in many ways, it's still a very fragile ecosystem. And at the same time, all of these open source tools are out there as a kind of excellent collection of base capabilities, but it's really hard to weave them all together for a specific community and manage all of the infrastructure needed to turn them into sort of end-to-end services. So what 2I2C tries to do, and this is the nonprofit that I'm the executive director of, is it tries to sort of facilitate a cycle of co-creation between these two communities, between scientific communities on one side and open source communities on the other side. The way that we do that is by managing and developing a global network of community hubs that are all geared towards interactive learning and discovery. So effectively what we do is we allow communities, and by communities I mean research groups, educational groups, collaborative, distributed research networks, define community however you want to design a hub that they can access remotely in the cloud that weaves together open source tools for learning and discovery, generally speaking with kind of open data and open science workflows. So that means connecting to resources like data and computation that you wouldn't be able to access by yourself. It means providing interactive resources, interactive visualization libraries, and tools that help you create interactive visualizations for your specific domain. And it also means exposing technology that's connected to a lot of the computing infrastructure that we run that leans into sharing and learning within a community so that you can kind of upskill one another, collaborate with one another more effectively. And what's really important is that all of these utilize the same fundamental building blocks that exist in the open source ecosystem. So general modular functional tools like Jupyter, but also things like NumPy, scalable computing libraries like Dask. We use these as kind of like Lego blocks and then build them together for a unique hub for a specific community, but where there's enough similarity under the hood that we can both make it scalable and we can start to see the patterns of where needs exist across this collection of tools so that we can collaborate with open source communities, improve those tools, and basically make everybody better off because we're all utilizing the same collection of infrastructure and building blocks under the hood. So at this point, we have a network of over 100 different community hubs. They're all running the same basic, common kind of open source Jupyter infrastructure stack, but they're for completely different use cases from, high level educational hubs for classrooms of up to 2,000 or 3,000 people to distributed interactive computing research projects that are, churning through 50 terabytes of satellite imagery data in the cloud. I think it's really a testament to how flexible this stack is and how useful it can be when you standardize infrastructure and deploy it via cloud infrastructure so that it's globally accessible. So I wanted to wrap up with what was an idea that I think kind of ties all of this together. And for me, the most important word on my mind over the last year or two is the idea of co-creation. And I think that both these tools are designed to allow scientists to co-create knowledge much more effectively by being able to reuse one another's work, to cross-link one another's work, to pull in multiple data sets and meta-analyze them in a much more frictionless way. But these tools and this infrastructure are also unique in the sense that the tools themselves are often being co-created by these international communities of open science enthusiasts, open source enthusiasts, and people who are just generally trying to work towards knowledge collectively more effectively. I'm also really excited to see publishing platforms like NeuroLibre, like CurveNote, which is another collaborator in this space, and like a number of other kind of ideas that this collection of tools has helped launch to explore what it looks like to make scientific ideas more shareable, more reproducible, and to make it easier to kind of co-create whatever knowledge we're trying to pursue as a collective scientific community. So that's really exciting. It's really exciting to see it exist both from the top to the very bottom of the tools, the services, and the end impact that scientists are creating. And I encourage everybody to think about how they can bring more co-creation into their own work as they're doing their scientific work in the coming years. So that's it for now. If you want these slides, there's a link to them, a little bit.ly link right there. There's a bunch of links in there if you want to follow any rabbit holes that might have interested you. And I'll be around for the rest of the day if you want to talk about any of this stuff. So thanks very much for your time.